So let's talk about VSS, or virtual switching system. This is the technology that allows you to take two separate switches and sort of combine them into one large virtual switch. So it looks like one switch to everyone else that might be connected to it. And it does this by actually merging the control plane of the two switches into one. So from a configuration standpoint, there's one massive config that configures the ports of both switches at the same time. And we also have an active and a path or a standby switch. So the active switch is the one actually controlling both the control plane of both switches. So it's sort of shared on the one there. And then if for whatever reason the active switch goes away, that standby can become active and take over the control plane responsibilities of at least what's left over on the switch that's still left standing. And the whole point in trying to take two switches into one is to have separate redundant, two devices for physical redundancy, but combine them into one so that we can essentially ether channel up to two separate switches. If we look at our topology here, this is what our topology normally looks like in a standard network without doing anything like VSS. We have two different switches at the distribution layer. So when you look at Cat 3 or Cat 4, it has a link up to Cat 1 and a link up to Cat 2. Well, they're two separate links, and most likely these are probably layer 2 links, right? And the connection up to controller 3 is probably layer 2 links. And so spanning tree is going to do its job. If switch 2 is our root, then probably this link is blocked between 1 and 4, and the link between 1 and 3 is blocked. And these links are probably blocked. Maybe you are doing an ether channel here, so at least you have two links there, but these two links over there are definitely blocked whether you're doing an ether channel or not on that side. So we're not using all of our links to their fullest capacity. But when we create VSS, what happens is those two separate switches now look like one physical switch. So from Cat 3's perspective, even though it's plugged into two separate physical devices, it looks like the same device. Same thing with Cat 4 controller 3. So now we could do ether channel both links. And rather than lose half my links to spanning tree, I can have all of them forwarding at the same time as long as I do ether channels here. And so that's really the big thing. It gives you back all the bandwidth that you're giving up to spanning tree doing its job of blocking these redundant paths in your network. So this technology in the wireless lab is one of those things I would probably consider it a lower likelihood. You never know. Any technology could show up in any given lab. But it's one of those things that's not really wireless specific at all. It really has no bearing or very little bearing of how we configure most of our devices. It's just, okay, can I bundle all, can I create an ether channel to this if it's split between two devices or not? That's really about the only thing it affects from a wireless standpoint. So they probably won't go into too big of a focus on this, but it's on the blueprint. It stayed from version 2 over to version 3. So if they kept it, I would assume that they might test it at some point. So you may want to at least know the basics of it. And we'll keep it at a pretty basic level. We'll just get the two switches combined, and then we'll create some port channels across the two different physical switches here. All right, so from a configuration standpoint, right now in Cat 1 and Cat 2, we don't have a whole lot going on. Show ether channel summary. I have one ether channel, but that's up to controller 1. I don't have any ether channels over here. And right now my links between the two switches are actually just access ports. They're at a completely blank configuration. Show run int gig 221, 22. No configuration whatsoever on these two links. So these port channels and these links actually are important in terms of our configuration. So when we start configuring these, a couple things to keep in mind. One, if you do have existing port channels, like I have port channel 10 right there, it's okay to have pre-existing port channels to some devices on switch 1 and switch 2 here. It's just they cannot use the same port channel numbers. Because what's going to happen is we're going to take two separate running configs, smush them into one large running config that has configs for every single port in it, which is fine for the physical ports because they'll get their own unique numbers. But these port channels, if I have port channel 10 on controller 1 and port channel 10 on controller 2, how do we combine that? That's where we're going to have a problem with that. So use separate port channel numbers. Ideally, do the VSS first and then create all your port channels after that. Number 2, we have to be able to create a port channel between the pair of switches, and this is called our VSL, or virtual switch link. This is used for traffic between the two switches once VSS is doing its job. So, control plane traffic, as we configure things on Cat 1 and it manipulates stuff going on in Cat 2, that's crossing the VSL. Or if I have, device A on Cat 1 that wants to talk to device B on Cat 2, it has to ride that VSL link to get between the different ports there. So a couple of uses for that, but that's a special port channel that we're going to have to create there. Okay, so basics. First thing that we're going to do is we're going to define a domain. So switch, virtual domain, and then give it a number. I'll use 10. And then within virtual domain 10, this will be switch 1. We can only have pairs of switches, so it'll be switch 1 and switch 2. But any switches that need to pair up need to use the same virtual domain. Okay, so on Cat 2, I'll do the same virtual domain number, but I'll say it's switch 2. So switch virtual domain 10, switch 2. Okay, so we've defined our domain and said I'm going to be switch 1, you're going to be switch 2. Next thing we'll do is we need to create the port channel for that VSL link. So int PO, and we need to use a unique number, so I'll do 21 on Cat 1 and 22 on Cat 2. So even though it's the same ether channel that I'm configuring, still unique numbers between the two. All right, so switch port, switch, virtual, link, and this is switch 1. So this is defining the port channel as that VSL link. And no shut. Similar thing over here, but just different numbers. So int PO20, I'll do 22 over here. Switch port, switch virtual link 2, so because this is switch 2, and no shut. Next, we're going to add those physical ports into this VSL port channel. So int range gig 2 21 to 22. And again, these are just blank config ports right now. So we'll do a switch port mode trunk, channel group 21, mode on. There we go. Send it. All right, we'll be okay for now. No shut. And then do the same thing over here. Int range gig 2 21 to 22. Switch port mode trunk. Channel group 22. Mode on. No shut. And then the last step is we actually turn on VSS. And this is going to cause our switches to reboot. So let's switch convert mode virtual. Do we want to do this? Yes. Same thing over here. Switch convert mode virtual. Yes. So it'll save our config, kind of convert it into a virtual switching config, reboot, and when they come back up, they should try to sync up across that VSL. So we won't make you suffer the long reboot times on these 4500s. We'll just pause the video, and when they come back, we should be back from the reboot. Okay, so at this point, our reboot is complete, and we actually did come up in the VSS SSO mode. So let's go ahead and take a look at just a couple things. So we'll go over to switch 2, which was our standby, was supposed to be our standby switch. And if we look at the prompt, interestingly enough, we see Cat 1, so it's no longer shown as Cat 2. This is now Cat 1 altogether here. And we do see a dash standby, so we know that it's not the active switch, it's the standby switch. And when you're standby, they give you a whole lot of options. You can do either exit or log out, so you choose whichever one you really want to do. The idea is that you can't really do anything on the standby switch. Now this will take over as active if you take out controller 1, reboot it or something like that. Cat2 will take over as the active, but it's still going to be, pretending to be Cat1 in this case. And if we look back a little bit at the logs as we went along, we can see that it initialized as the standby processor. There we go. So we see that on the active switch. We can actually do our normal configurations here. We see that it came up as the active processor. It reached out, and if I can get down to where I want to see. So it's initializing being the active supervisor. We see that if we can get down, sorry, a little bit farther. There we go, our interfaces join the port channels, port channel 21 being my VSL. And communication with the peer supervisor has been established, so now they can talk to each other across that VSL. Then they do their little sync up and communications, and that allows things to work. So a couple of verification commands that we could run. Again, everything's run on the active because we can't really run any commands except for those two wonderful commands over on the standby one. But show switch virtual. So we can see that switch mode that we are indeed in a virtual switch, that we are using that domain of 10. The local switch is switch 1, and then the other switch is switch 2. So there's a couple real basic pieces of config there. We can also add role to the end of it and see a little bit more information here. So just play around with the commands. There's a few other things that you could look at, but once it's up, now, if I do a show in status, and if I actually type it right, we get a little extra number in front of things. So it used to just be, 10 1/1 or gig 2/50. Now they add the switch number to the beginning of it. And so that's how we get a unique port number between switch 1 and switch 2. They didn't just add, if I had slot 2 as my last slot, they didn't just say like 3, 4 or something like that. So no, it's switch, slot, port number. And so once I get slash the 1 slashes, and now here's all the ports on switch 2. Everything's starting 2/whatever. And so now I can go ahead and just configure the ports on either switch that I want. And here's my port channel. So again, both port channels all kind of came together. That's why you don't want to have the same port channel number, because we're going to have to merge these two configs. Now that I have this virtual switch up, let's go ahead and create some port channels. We'll start off with Cat3. So from Cat3's perspective, let's take a look. Show CDP neighbor. I have 2, and they both say Cat1. So it looks like the same switch, at least from CDP is saying that's the same switch. We see the ports that they're on. Good stuff. Let's create the port channel. So int range gig 1 0 21 22. There we go. And we'll just say channel group 3 mode active. We'll go on the switch Cat1 int range gig 1 /2/23 and gig 2/2/23. Channel group 3 mode. I'll do active on this side as well. Takes a little extra computing in the old head there to try to figure out what my port numbers are. But there we go. Show ether channel summary. And now, cool, I successfully have a multi-chassis ether channel here. Cat3 is ether channeling to 2 separate physical devices that are just pretending, well, they are one logical device here. And we could do the same thing to controller 3. We could create a 4-port ether channel. So do the same thing again. Int range gig, so it's on switch 1, 2, 11 to 12, and 2 to 11 to 12. Say channel group 4 mode. And why don't we do PEG P here? And go on the other side. int range TE1, 0, 1 to 4. Channel group 4 mode desirable. Use PAG-P on that side. And let's see if we actually get the ether channel to work as expected. Whole bunch of downs. Show in status. Disabled, that might be why. Int range T10 1 to 4, no shut. See if that gives us what we want. All right, it should be attempting to come up now. Show ether channel summary. They're making their way up, and that's what we want to see. So now we have 4 ports, all capital P's. We have the SU port channel up again across 2 separate devices. So that's what VSS is really giving us. Now I can use every single link on controller 3. I can use every single link on Cat 3 or Cat 4 if I so chose. Now, I don't know that they would ask you to do this, but let's say that you had to get out of VSS mode and go back into standalone mode. Again, I don't think that they're going to ask you to do that, but just in case, let me show you how you can do that. It's pretty simple, although there's a lot of cleanup afterwards. So back on just enable mode, not in configuration mode. Switch, convert, mode, standalone. And we can only configure this on the active supervisor, or the active switch right now, right? Because we can't configure anything on the standby. So what's going to happen here? Do you want to do this? Yes. All right, so my switch is going to reboot. As this goes down, what's going to happen is Cat 2 is actually going to take over as the active switch for VSS. And so without too long, there we go. And now I'm no longer the standby switch. I can do my configurations. Same thing over here. Switch, convert, mode, standalone. Yes to this. There we go. And it's going to reboot. And at the end of the reboot, what I've seen in the past, and it's probably going to happen again, is all of the ports were disabled. So there's going to be a whole lot of cleanup to do. You're going to have to go through all your ports, make sure all the ports that should be up are up. You might have to reconfigure some ports. So for that reason, I don't know if they would be that mean as to force you to leave it, but just make sure that after you reboot, come back up in that standalone mode, look at all your ports, make sure that they're all administratively enabled, no shut them, make sure that you didn't lose any configurations, that everything's still, an access port or a trunk port or whatever it's supposed to be. Take a peek at those port channels just in case. So again, unlikely, but just in case. So that's really VSS. Pretty basic, again, probably not something that you're going to see in the lab, but just in case that they do want to throw this at you, you should know how to get this working.